and have a good day. So as promised, I'm going to make a new video regarding our last topic. So this is our last topic, our module 8, which is last things. So this module, mostly you're going to play around with mathematics. Are you happy or not? As for me, I'm going to be happy because I love mathematics rather than all the theory, all the stuff that I need to memorize, the definitions, the descriptions, and all the thing I really had. But this last topic, we're going to look into more to the equation. Yeah, you play around with numbers. So it is going to be under performance measurements and analysis. Okay, let's say you are doing some project, or maybe you did develop for your computer science, maybe you develop an application. So what that application, okay, maybe you develop chat application. Okay, so that chat application, when you develop, then you want to document it, right? Like you need to write up a report or maybe a thesis. So normally you will say like a conclusion, this chat application much uh, much faster than WhatsApp, let's say. This chat application is more friendly user rather than WhatsApp. This chat application only occupy uh, lower bandwidth for the internet. Same goes like currently, if you can also differentiate between like Google Meet, Webex, Zoom, so you can find out that Webex is higher in bandwidth. So if your lecturer are using Webex, so normally it's require you to have a high bandwidth for your internet. So you punya internet quota, if you just using your mobile cellular network, so you punya mobile data tu akan laju, it's going to be like faster rather than compare using Gmeets and so on. So uh, you will say like more faster on the bandwidth, maybe it's only occupies small bandwidth. So you talk about that in term of wording. So if you like presenting it to any panel or any people that you want to sell your chat application, so they was like thinking, what is the proof? Maybe what is the proof that it is fast? What is the proof that the bandwidth is lower? So on the performance, you said the performance of your chat application is much better, but how you want to justify? How you can justify and prove it? So that's why you need to come out with numbering. Let's say, okay, my chat application uh, is faster 50% faster, or maybe 50 second faster rather than WhatsApp. So there is a proof that in term of numbering, or then people will know, oh, how much the faster or the differentiation between each other, rather than you just it is much faster. So people won't know how much it faster. So let's say you talk about the bandwidth. Okay, my chat application just occupy, let's say, small bandwidth. But if you compare with this, my application, the chat application, only need 10 uh, megabyte. I forgot. Megabyte. Is it bandwidth? Rather than the WhatsApp, let's say. So maybe also you can say it reduce 20% rather than if you compare if you use WhatsApp. The bandwidth is reduced until up to 20%. So people will know, oh, this amount. So you can justify your performance of any kind of project and everything's in terms of numbering. That's why you're going to apply mathematical things and terms in your module 8, because you're going to play around on the performance measurement. Of course, measurement is something that you can measure, you can calculate. And also the analysis is something that you need to analyze uh, on the project or whatever. So the objective to understand the key performance issues that related to computer design, explain the reason for the move to multi-core organizations, and understand the trade-off between cache and processor resources on the single chips. To summarize some of the issues in computer performance assessment, and lastly to discuss the benchmark in general. So maybe sometimes you not going to be like understand it fully because some of the term is new for you, right? So we move first for the introduction. Introduction is very small. Okay, so introduction. Hardware performance is often key to the effectiveness of entire system of hardware and software. So this is the hardware performance is the key. For different type of application, different performance metric may be appropriate, and different aspect of computer system may be the most significant factor in the determining overall performance. So if let's say you have different kind of application, maybe it is similar application but similar application like, okay, let's say pen. There is several publisher that publish a software under a pen. So same type like words. So you also have a different kind of texting similar like words software or applications. So this it is same similar type, but of course they are because it is different application, not different type. Okay, so different application, although the type is similar, it is going to have different performance. Same goes what I give you the example before this, which is you create the chat application. So WhatsApp also a chat application. Both are a chat application which is having a similar type, let's say similar type of application, but the application is different, so it's also can have a different performance. But of course, when you have different type of application, it can clearly see that you're going to have different performance metric. What is different types of application? Let's say you open PS Photoshop rather than just a pen editor. Of course, Photoshop will cure and also request more bandwidth, more processor time. Also, it is really increase. Your RAM will be also reduced fast because you open your Photoshop and so on. So that is about these sentences. Understanding how best the measure of performance and limitations of performance is important when selecting a computer system. So this is talk about computer system. Let's say you know that this kind of computer, your laptop having, let's say, on the performance. So how about the performance maybe on the RAM? So it have a 8 megabytes RAM, let's say, compared to 16. Which one is better? Of course, you're going to pick 16, right? And about the limitation of performance, also maybe Limitation of performance. So there is a lot of performance limitations. Let's say one of that it's like a clearly that I can show you. Maybe you differentiate between two different OS. Like Microsoft Windows and also Microsoft and also MacBook. The iOS. So it's going to be also different in performance, like, right? So that's thing. Assessing the performance of computer can be quite challenging. Together with the wide range of performance improvement technique employed by the hardware designer have made performance assessment much more difficult. How about the difficult? I don't know yet. Let's go through. To understand the issues of assessing the performance, you're going to see that you're going to ask something in your own mind. Why a piece of software perform as it does? Why one instruction set can be implemented to perform better than another? How some hardware features affect performance? So these all might be asked in yourself regarding the issues on the performance. So let's we go deeper on the defining the performance. So we're going to look into the overview, throughput, and also response time, relative performance as performance metric. So throughout all of this, you like need to know on uh, the definitions, but the rest is only on the equation, how you're going to apply into the equation. So there is not a lot things that you need to remember into your memories if you compare to a previous module. So previous module, a lot of definition, a lot of descriptions, a lot of the pictures and etc that you need to remember, right? So I guess this module is much more easier. When we say one computer has better performance than another, what does we mean? So this is what I mentioned. My chat application better than WhatsApp. So how you define better? How you define better? So this is not a something that you can justify your performance, including like a computer performance. You cannot say, okay, I think uh, the HP computer is much better than if you compare to Asus computer. So you just mentions about better, which is it's too rigid. It's too like too loose. Your justification is too loose. So you need to find something that you need to prove in terms of the performance. Although this question might seem simple, because what does you mean? What does we means on the better performance? Although it's quite like simple, an analogy with passenger airlines shows how subtle the questions of performance can be, which is in our next slide. Okay, these have several airplane. So you have a different kind of airplane, Boeing 777, Boeing 747. So which of these airplane has best performance? Which is best performance? How are you going to justify whether you want to check whether it's having a highest number of crushing speed, or maybe the longest range, or maybe on the largest capacity? So you're going to have like a few things, like a passenger capacity. Which of the airlines support more passenger capacity? Same goes to your computer. If you compare with one laptop, Asus and HP, you're going to also like compare the storage capacity, the processor speed, like cruising range miles, maybe on how weight your laptop is, and over here cruising speed and passenger throughput. Passengers, you're going to see, maybe I don't know, maybe you heard this word first time. Normally I think last time throughput, yeah, maybe at your first year you're going to find this is like a new terms also, throughput. So later on you will say what is throughput. You can also like always Google what is the meaning by throughput. So you can see the rate at which the airplane transport passenger, which is the capacity time, the cruising speed. So considering different measurement of performance, so you can say it in terms of, okay, the airplane with the highest cruise speed is Concorde. Was the Concorde retired from the service? Where is Concorde? This one. Oh, okay. This airplane is higher in speed. So you can see over here it's higher in speed. So if you compare, okay, in terms of the performance for speed, this airplane win. But maybe on the capacity of passenger, it is low. So it lost it lose and at the passenger capacity. The plane with the longest range is $DC850. This one is cruising range in miles. And lastly, which is the plane with largest capacity is Boeing 747, which is having the highest, which is 470. So different kind of things, or maybe measurements of whatever performance is going to come out with difference. So let's suppose we define performance in term of speed. If you look into in term of speed, who going to win? If let's say we look into the performance of the capacity, how about the performance of the storage? Which laptop is going to win? If we look into the performance of processor, which laptop will be win? Same goes to the airplane. So two possible definitions: performance based on speed and performance based on the throughput. Now you're going to see the throughput again. You could define the faster plane as the one with the highest cruising speed, taking a single passenger from one point to another in the least time. So this is the Concorde airplane. We already look into this. And how about the throughput? If you were interested in transporting 450 passenger from one point to another in the fastest time, as the last column of the figure shows, it is 747. So similarly, we can define computer performance, as I also give you example on the computer, right, in several different way. So throughput and also response time. We might interested in the reducing response time, the time between the start and also completions of tasks. Let's say when you open your computer or laptop first time, you're going to have like loading, right? Loading. But sometimes for the very fast computer, you rarely see the loading things. But for my computer, sometimes for my laptop, sometimes it happen because my processor, I don't know, maybe I occupy, there is a lot of thing. That's why sometimes I love to remove things when I just did something, but sometimes I forgot to remove, so there is a lot of things that burden my laptop. So that's why if let's say for my recording, sometimes you can hear the fan sound. Not just now, right now also I hear the fan, and it's quite hot, so I cannot put my laptop. So you can see over here, it also refer as the education time. So to make the completions, just to like reboot your laptop. So it is a one task. Or open your Microsoft window. So it is open the Microsoft Word. So it is a task. Then you're going to be like loading for a while. So that is education time. But for the speed and highest performance of computer, of course, it's going to be like you double click and then suddenly it pop up. Okay, it's already open your Microsoft Word. So that is what we want in our computer or laptop. Increasing throughputs or bandwidth, the total amount of works done in a given time. So let's say you have maybe you can do a parallel work together, and then you can like finish it. So your throughput and also bandwidth can help you in terms of giving you many output in short time. So you need to increase the throughput and also bandwidth. Hence, in most cases, we need different performance metric as set of application to benchmark our personal mobile devices, your phone, which are more focused on response time, versus servers which are more focused on throughput. Okay, this is the computer performance measurement. Is it computer? Yeah, type of computer. You have Samsung, you have this one is what OCZ. I never heard about this. Maybe I'm too old for this technology. Patriot, Hellfire, Intel, or maybe it's too expensive, which is I cannot afford to buy, so I don't know. So this is also similar. Different or similar? This one is different. Okay, some is similar, some is different. But throughout over here, you can see there is a difference on the throughput and response time. So in this left picture, it is looking into the throughput. But in the right picture, it is a response time. So there is example. Do the following changes to computer system: increase throughput, decrease response time, or both. So what you need to do if you need to change your computer system by increasing the throughput and decrease the response time, how and what you need to do. Replacing the processor in computer with faster version. So what happen if you replace your processor with faster version? Is going to be like increase the throughput or increase the response time? B, adding additional processor to a system that use multiple processor for separate tasks, for example searching the web. So this keyword, I guess it's on throughput, but let's see the solution. First, decreasing the response time almost always improve throughput. Hence, both response time and throughput are improved if you replace the processor. So you're going to decreasing the response time, and also almost always improving the throughput. So this one is vice versa. If you have the throughput and also response time, if your response time is decreased and your throughput will be increased. Hence, both response time and throughput are improved. Mm? Wait, decreasing response time, decrease. Always improve the throughput. Hence, the response time and throughput are improved. I need to check this back. No one task get work done faster. So only throughput increase. So if let's say you have like in term of addition processor, but the processor is similar type. It's not like changing to the faster processor, but you just increase the numbers of processor to use the multiprocessor for separating tasks. Let's say one processor you open your window words, one processor you are opening your PDF. So you're going to finish your uh, several tasks, the amount of work. So several tasks you can done in a given of time. Maybe in one time you can have 2 tasks finished all together. So it's going to be, as I mentioned, it's going to be increase your throughput. So this one I need to check it. But if let's say you can justify it, maybe you can also share in our class, okay? It's better for like we have something that in come out in our mind. Maybe we just want to uh, sound it and make it out from your mind and share with others. It's very good rather than you just like keep quiet and just okay, I accept whatever the lecturer said. So relative performance. To maximize the performance, the response time or execution time for some tasks should be minimized. So this is for you to maximize the performance. Thus, the relationship between performance and execution time for the computer is always like vice versa, which is you have the performance, you're going to have something that 1 over your execution time. So this will be your performance of your computer. This means that if let's say you have 2 computers, you have computer X and Y. If performance of X is greater than Y, this one you always like say, my performance of my computer is higher rather than my friend. And your friend also claim, no, my laptop is higher than your performance of your computer. So how you going to justify it? You're going to check both of your execution time. And then you're going to see, oh, who get the much higher in the kind of performance. The execution time of Y is longer than X if X is faster than Y. So you can see this is like correlation. If let's say performance X is much better, then you're going to have what, 1 over something. Then of course it will be higher for a Y, because this one is already higher. Maybe you can play around with, let's say you put this as a 10, this is 5, because it's much higher, right? So 1 over 10 you're going to get 0 point, put it here, 0.1. But if you 1 over 5 I cannot cok. Okay, 1 over 5 you get 0.2. Sorry because I already old, so my brain is getting slow. So I think I can make a correlation between how old the person with the brand performance. So for myself, my age increase, my brand become low in performance. So maybe this kind of things. So same goes to the performance versus the education time. So you can see your education time for your X is 0.1, and your education time for your performance of Y is 0.2, which is much higher. So it's going to be like this, isn't it? This one is Y. Please make sure. Okay. So if X is n time faster as Y, then the education time of Y is n time longer as X. So let's say I give you example, we pick any kind of value. If X is 2 times faster than Y, then the education of Y is n. So let's say we have like 2 times faster, n times faster, 2 times faster. Performance, okay? 2 versus Y. Of course, if it's 2 times, the Y will be 1, equal to education time for your Y. Let's say because it's 2 times, right? If let's say your education is the times for Y, then the education, if the n time faster, if X is n time faster. Okay, let's say for your this one is X, it's going to be like 1 second, and because this is 2 times faster, kalau faster, it's going to be education time, education time for Y is longer than X. If X is faster, okay, then you're going to see you have 1 over here. This is for X, right above. So the Y will be 2 times lowest for the X, because it's Y versa, right? So after that, if you compare like 2 divide with 1, and maybe you don't know about the education of X, so how you get X? X equal to 2. So this is the education time for your Y, for your X, sorry, for your X. This is education time for your X, and then this is the education time for your Y. Kenapa I ni salah? X, Y, X. Okay, how you going to get your Y is, of course, you're going to play around with your mathematics, and then you will get 0.5. See, I also already forgot the mathematical things. So this is just like example, but you're going to see that performance and education time is going to be vice versa. It's not going to like if you're going to see how the graph, if the correlation like this, it means that X, and over here it's also X. But if you have vice versa things, I think it's going to be like this. I don't know about the graph, but you need to know that it's vice versa for X and Y. That's why it's 1 over some things. So you're going to get the value of n. And all this kind of value will be given in the equation. Only that maybe it gives you the value of n, it gives you the education time for Y and X. You need to find the performance of Y. and performance of X also is given. So this is play around with the equation. So example 2, if computer A run program in 10 seconds. So already see over here, a program running 10 seconds. So the execution time for the A. And the computer B run the program in 15 seconds. So this is how much fast? Oh, this one is the performance of your computer A, computer B. So you're going to find out what is the how much faster A if you compare versus B. So you need to find the value of the N. So you're going to apply it into your equation. This one is execution time. Again, it's true. So execution time for your A and also for your B. Going to see, you're going to apply to this is computer B, 15 seconds. This is computer A, which is 10 seconds. So you want to compare between how much faster A if you compare to B, because you want to check the performance of A compare to B. That's why you need to key in the value of execution time for B up here, and then you compare with the execution time of B below here. If let's say the question asking you vice versa, how much faster B than A? So what you need to do, B is up for the performance compared to the performance of A equal to execution time for the A. For the A, execution time will be 0, and then execution time for the B will be 15. How many you will get? So you will get 0.666666667. So this is the performance comparison between A and B, B and A. But if let's say for A and B, it's going to be look like this. It depends on the value itself. So this is the ratio. Okay, what unit metric that you normally going to use in to check your performance? You're going to play around with MB per S or megabyte per second, and MIPS or millions of instruction per second, CPI clock cycle per instruction, IPC instruction per clock cycle, Hertz Hertz ni kalau tak tahu juga, I don't know Hertz processor clock frequency cycle per second, LIPS logical interference per second, and lastly your FLOPS, which is floating point arithmetic operations per second. So when you see this metric, normally you will know, oh, this Hertz for frequency. I know this one only. So the rest also you need to know on the metric. So before we already end our definition performance. Now we're going to look into this 8.3, which is basic measurements of computer performance. We're going to look into the overview, the clock speed, instruction execution rate, CPU performance, classic CPU instructions count. I think I'm going to spread this video, so I'm going to stop it now. Later on, we're going to have another video, which is we're going to continue our 8.3. Okay, Thank you for your watching. Don't forget to study smart. Bye bye.